I think Carson gave us a very good example of how to build a model. Right? Very detailed explanation of defining the problem, do the feature engineering, try the method of building a deep learning model and evaluate the performance of the model. That was very good. But my talk will kind of fly up and give you a bird's eye view of how data science is doing, what data science is doing, and how to maximize the benefit of data science product in a business. And more important, because we have students, we have a lot of friends in this room talking about, we gotta change career from some other industry to data science. How can we do it? And also, we have different experiences in this area and how we grow in this profession. Because relatively, this is a new profession. I have not been called like data scientist until probably 2012, 2013. Before then, actually, I was doing quite similar work, but nobody called me data scientist, and nobody called anyone data scientist before. So it's a real, it's a new area. So I want to share some of my observations just based on my teaching experience in George Washington, and also my working experience in various companies. Some failed in data science, some succeeded. What I'm doing now is trying to bring the value of data science, machine learning into this company. So right now I work as the VP of Data Science and Applications in Celera. And my topic, first of all, my topic, a little bit catchy, so it's beyond data and beyond science. So there will not be a lot of technical discussion like Carson bombarded you with, but will be more like generic and storytelling and more easy way. Hopefully will just a little bit exchange of ideas. So those things will be you're not going to learn that from school. You're not it will be hard to read it from schools from the books. But I welcome any questions and comments. Only represent my own personal view, not my company. So a little bit myself. So I got my PhD in operations research from George Mason University. Then I started and conducted a lot of optimization simulation in civil aviation. So I worked with FAA and NASA for many years. Then I got out of the aviation industry and got into the data science profession, like in 2013 and 14. So I did a lot of different predictive modeling work. And by the way, this is a word cloud just trying to highlight myself. Across everything I did, I can only use one word to summarize the common ground of my different jobs, which is risk. So the risk in civil aviation, like how likely the two aircraft will crash into each other, and the risk of the drug shipment, illegal drug shipment to get into the country, which was one of the projects I worked for CBP, and now I'm working in cybersecurity industry. So what's the risk of your network got hacked and you have malware in your system, and someone is stealing your credentials? So everything is about risk. And we're using machine learning algorithms and methodology to attack those problems. And I really love to build community. So I love sharing, I love talking, I love making friends. So that's how we get here. So that's a little bit just about myself. Very quick introduction about the company I'm working in. Celera is a very new company, founded in 2017. Its vision and mission is to protect healthcare providers, which basically the hospitals, from the hackers, from malicious the attack vectors get into the system, stealing patients' information, and even more dangerously, can hack into those medical devices and change the diagnosis and the doses into those medical devices and hurt patients. So this really life and death matters. It's very, very dangerous and very critical. So we are dedicated to providing the cybersecurity solutions and also operation management solutions to hospitals so that we can manage the large fleet of medical devices. And our product include a few modules like MedView, which basically give us a situational awareness of what the systems, what the devices are in network and how they are doing. Then the MedWell is doing some kinetical analysis. Then Fortify is more like a cybersecurity defense. Then the defense is more like proactive defense. So I joined the company like half a year ago, more than half a year ago. So my goal is to bring big data, bring data science, machine learning, the value of those cutting edge technology into the product, and then fully bake everything into the product. So that's what I have been concerned with since then, and actually before then, because when I was working in different sizes of companies, I've seen that although many companies has data scientists or have data science team, although they may not call it data science like statisticians or modelers, quantitative modelers, but they're doing the same thing. They're building the product. They're trying to doing the research and make their product more intelligent, or trying to find patterns or knowledge, insights from the data. But some failed because they couldn't turn the insights they found from the data into something tangible and workable in the product. And some succeeded. And hopefully we are on the right path of doing that. We are facing a big challenge because we are collecting the network data from large hospitals. So every second we're generating 5 gigabytes to 10 gigabytes per second of the data volume, which represented everything on the network. And how we can process that amount of data and how we can make sense that amount of data and draw insights and predict and detect something going on right now, right then, right at the moment. So that's the challenge we're facing. It's way more than just fine-tuning an algorithm or make a product have improvement by like 2% lift, as Carson said, such and such. So that turned my attention from individual model building into the question of how we can build a product with machine learning models and intelligence in the core. So we can turn a software product into a data product, which is the truly, really in the essence, the value of machine learning. And that's the future of this community, this discipline. Because if we cannot bring the value of data science into the business, you will die soon. So that's the concern. And that's what I'm going to share with you about some of my observations and experiences. This is a very interesting cartoon. If you cannot read the caption here, it's that, so there are two guys here. One is, this guy is interviewing with this company, this employer. And the employer said, I'm not surprised with such extensive predictive analysis experience you have. You should have known that we wouldn't hire you. So, if you're so smart, if you're so good at predictive analysis, you would know that you have no chance to get into the company. And this guy is very sad and very surprised. He said, why and how? Why? And we may always, each of us have the experience of finding a job. I looked for a job before, and I interviewed before. I got rejected before, and I believe everyone has such experience. We definitely can feel for this. Sometimes it's hard to view ourselves as a data point, right? It's hard. Although we have resumes, but the resume cannot catch everything about ourselves. I think it's a problem we may have. So it's really hard to put us in the spotlight and say, I'm going to analyze myself and see if I am a good fit to this company. Sometimes it's very easy for us to overestimate our competencies or expertise or experience and say, I'm good at this, I can do this, I definitely can do it. But from the business perspective, it's a different story. So I'm going to use this cartoon to talk about data science from two perspectives. One is from the employer's perspective, from the business perspective. What kind of people, as an employer, I should hire, so that what kind of data scientist the employer should hire, so that it can bring into the business the best value nobody can ever get. And from the candidate's perspective, as a job seeker or as a potential candidate for this data scientist role, how I can maximize my capability to win this opportunity, to get this position. So how I can grow in my career. So I'm going to talk from these two perspectives. So first, what is data science? Why we have this job called data scientist? The title of this cartoon is called "The Rise of Data Scientists." Many years ago, you are this guy. Nobody talked to you because you're just a math geek. You're just a nerd. You wear glasses. You seem smart, but nobody want to talk to you because you're not social. You're not very good at sporting. You just feel lonely because you're just a math geek. But now, all of a sudden, you're getting so popular. Everybody comes to you, talk to you, and wanna know how you be so smart and how you can build a very intelligent model, can do this thing, can predict that thing. Because your name changed. Your name changed from math geek to data scientist. So that's all of a sudden you get popular. But there's still a lot of myth about what is data science and what the data scientists usually do. So, but still, we are on the very early age of this profession. So there are a lot of confusion over there. Some say it's just data science is a fancier name for statistics. I mean, it has some truth because statistics is really important building block of data science. Statistics provided a lot of theories, algorithms into data science. I remember many years ago in 2014, I wrote a blog post. It's called "If Data Science is a Car." If we look at data science and just use a metaphor, say data science is a car. What's the statistics? Statistics is the outlook of the car. It looks like statistics. So the car itself, data science, just by the look, it's pretty much like statistics because you're trying to get inference from statistics, from the data. You're trying to identify the trend. You're trying to get the probability. You're trying to get the distribution. But data science is much more than just the statistics. It has a lot of heuristic algorithms. It has a lot of methods borrowed from information theory, from optimization theory. So it's way more than just statistics. And some people may talk to you. It's just we don't know those data scientists are doing. They just cook some secret recipe. They just want to crunch the data so that get a result or get a conclusion that the bosses, the management would like to see. So that's kind of very biased arguments. Definitely, data science is built on very rigorous and solid foundation in mathematics and also in a lot of other like information theory, signal processing, optimization on those foundations, and probability theory on those foundations. So I like the definition of data science in Wikipedia. Based on Wikipedia, it says data science is a multidisciplinary field. It's a multidisciplinary field. It's not just a single discipline. It's a multidisciplinary field that uses scientific methods, processes, and algorithms and systems to extract knowledge and insights from structured and unstructured data. So it covers a lot of things here. So first, data science is not a new discipline. It's not a new at all. It's a overarching field, covers statistics, probability, mathematics, especially linear algebra, then mathematical optimization, information theory. A lot of computer science, a lot of traditional discipline. So it's a combination of those disciplines, but uses scientific methods, a lot of processes, algorithms, and systems. So data science is built on top of systems. It's not just algorithms. So data science is actually very pragmatic. It's very applicable. It's not a pure abstract algorithms. That's the whole point I try to convey here, is we need to have the system and view data science as applications and systems to extract insights and knowledge from the data. So we are overwhelmed by data, but as a human, our brain is not able to digest and process all those information coming to us 24/7. We have to rely on some automation, help us to process those data, extract the knowledge and insights. And eventually, we got to use those insights and the knowledge. So that's how data science it is. So it's not a myth. It's not a secret, recipe cooking. It's built on top of very well established disciplines, and it's focused on applying those techniques and algorithms to build up systems and applications, extract information, extract insights and the knowledge, and apply those knowledge and insights to the product, so that can help us to get the best out of this business. But the thing is, do you feel the impact? Does the business really utilize the data science so that it brings positive impact to the business? According to some study, 60% of companies plan to double the size of their data science team. That's good news for the job hunters or the career changers, or anyone wants to move the ladder in the corporate ladder. We have a lot of job openings in data science realms in this area. And 90% of the business believe data science would contribute to the business solution or business innovation. So they have very positive view in the value of data science. So, just conceptually, they think data science is good. Data science is the future. They can talk about these buzzwords for hours, for days. But when it comes to implement it and really carrying this out, that is how the business suffers. It only less than 9% of the business can actually say and quantify the business impact of their business models or of their data science models. So this is a real challenge. It doesn't matter if it's a big company or small company, almost every company who is willing to embark on this journey of having data science on their business, they're facing the challenge of monetize the investment in data science. How they can quantify the value of the data science models, machine learning models. They put a lot of human effort, they put a lot of money into it, but it's hard for them to quantify the value out of this investment. So this cartoon is very, very interesting. It's actually it's just spot on. It says after we carefully consideration of all those 437 charts and graphs and the metrics, basically I just give up. I just throw out my hands. Let's go to the liquor store and got drunk. Because all those graphs doesn't make sense. Although we have those big data, we have those dashboard, very fancy. It's just so hard to make sense out of it. How we can make sense out of this data and insights and all those dashboard? How we can really bring the value of data science home to make the business better? So I'm going to talk about some potholes of doing business in business. Potholes in Chinese is 坑. What's the 坑? in the data science business, right? Doing data science in the business. So let's first review the data science life cycle. It actually, although it's very straightforward, it's plain. You probably have seen this many times in the classroom, in your business, your company conference room. Many people talk about this. It become a cliche, but now every time when you really look at those workflows, actually it bring me new insights, bring me new thoughts about this. So let's just review this. So this is a data science life cycle. You start here and end here. The start point is the business understanding. You always start doing a data science project from understand the business goal. What's the meaning? What's the point of doing this project? What's the meaning of analyzing this data? What you want to get in terms of the role and the contribution of this project will make in the business. So what is the use case of this business environment, this business sense? So once you have a good business understanding, then you start with collecting data, do some EDA, exploratory data analysis. Sometimes you will see that actually modeling and the data. So here is the data acquisition and understanding, and here is modeling. Usually you will see that it is sequential. You have modeling after data, which doesn't make much sense to me because of course it does make some sense, but it's not 100% correct. Because the ideal case is, when we are collecting data, we're already thinking about how we use the model to do the EDA on the data and what kind of features we can build for the model. And during the modeling process, we come back and realize what kind of data we want to have. So it's really an interactive two procedures, and they have a lot of interactions. So we should have this two component shoot by shooter, not in a very sequential. You're not going to have wait for the perfect data set until you will start the model. So because you will never get perfect data set. The data is always, you have missing values, always have a lot of issues. You always, one have that data, and you're not going to have it. But you need to start the modeling as soon as possible. So it's really a in parallel process through the modeling and the data acquisition and understanding. The modeling part actually, that's what the data science focus a lot in the modeling. We do the feature engineering, the model training, and the model evaluation. Then from this process, we realize what new data we should have and how we can acquire those data. And if we don't have the data, how we can get those data, and how we can clean and the pre-processing, and how we can. So we have, I know the font is very small, and the data, where the data stored, either on the premises locally or on the cloud, and the data coming in batch or come in streaming. All those kind of information, how we can wrangling the data, exploring the data, and cleaning the data. And everything contributes to the model. Then once we have built a model, which basically follow the procedure Carson talked about, go from the feature engineering, model training, then evaluating the model. Then the next step, he didn't talk about actually, is how we can deploy the model. If you don't have this, if you stop here, you never reach to your customer. It's not a finished mission. It's not an accomplished mission. You can do a lot of back and forth between modeling and the data. You can make your model 99% correct, 99.99% correct, but it doesn't bring the value to your business because unless you deploy the model so that your customer can use it and bring value to the business, you're not going to justify the time and the money and the resources the company invested in building the model. So the deployment is something, as data scientists, we lost the visibility to it. So we don't really know much about how we can deploy a model. So the software engineering is talking with some language data scientists don't understand. And data scientists talking with some language the software engineers, they don't understand. So it's really hard to, just like chicken talk to the duck. They can't communicate. They don't know what is AUC. They don't know what is ROC curve. They don't know what is feature engineering. They don't understand why you have to iterate your model. And they don't understand why your model takes so much memory and use so much disk drive, and how we can fix those problems. So that's the deployment problem. And we eventually need to get our visibility into the deployment. So we need to understand how the model is deployed and what kind of data will be digestible, come in, come out, and how they gotta use and consume the output from the models. But once we have a successful deployment of the model, then it becomes part of the product. Then the user can use the model, can use the product driven by machine learning, then send feedback into the model. So we have the customer interaction, we get feedback, which is very important. So help us, data scientists, to revise and improve and realize the weakness of the model so that we can make it better. So this is the overall life cycle of a data science product. We do this a lot, day and the night. That's our bread and butter. So we do this as a means for making our living. But the thing is, we put too much energy and effort into this, and we put very little effort into knowing this part and this part. So that's what I want to emphasize is, in the business, if we want to maximize the value of doing data science in business, we need to be fully aware of those life cycles, each of the components, and also be aware of those potholes in doing the data science here. So the first pothole is as no goal. Although the business, the company, they just because everybody has data science team, and how about we have some data science team and just hire some intelligent guy from GMU, or from GW, or from any some. Actually, there are more than 200 universities providing the data science programs. So that's no shortage of universities sending out data science graduates into the job market. But the thing is, there are a lot of problems. I'll talk about that later. But the data science, the business, they create the data science team without much idea of how they can use data science team. So a lot of times, the team is outside of the core business. It has nothing to do with the production, it has nothing to do with the customer, it has nothing to do with the data. It's just, okay, you 5 people, this is the office you have, and you can do whatever you can. Every month you just show us give us a brown bag or presentation, and show what kind of smart solution or model you have built. Then that's it. After you have shown them, this is the perfect model, this gave us a very good accuracy in predicting this customer will default, or this system will get hacked, or whatever. Then that's it. After the report, after the presentation, everybody go back to their own business. So from the high level of the management of the company, they don't understand data science. They don't understand the value of data science. They don't know how to what kind of the goal they can use data science, which is a group of very smart people, very motivated, very intelligent people, to help them to make the business better. So no goal. The second is actually very ironic, is they don't have data. It's kind of like very weird situation. Like many software company, they make software. They develop software. Then they ship the software to the customer. Then the customer run everything, and the data just accumulate on the customer side. But the software maker, the company itself, they have no access to the customer's data. I mean, you understand that, right? Because the customer don't want to share the data with the software company. They don't want to, privacy, trademark, trade secrecy, the business, confidential. For any reason, they just don't want anyone outside of the company to have access to that data. So the software company, they have no access about, how their product is doing, how the customer is interacting with the product, how the product fails, how their model fails. They have no idea because they don't own the data. Everything else, everything in the software is built on rules. It's built on subject matter expertise. They have some, in my industry, cybersecurity, each cybersecurity company has a group of cyber security experts. So they come up with a set of hundreds, thousands of rules. They build up those rules in the system. But once they ship the system, they have no idea how those rules perform. They have no idea which rules trigger and which rules are not triggered. They don't know what's the false positive rate. They don't know what's the false negative. I mean, we don't know the false negative, of course, because if something going on, we didn't detect that, we don't know until someone steal millions of customers' data. So those kind of thing is hard. They have the software develop company. They have no data to give data scientists so that data scientists can use those data to improve their product. Then the third one, if you have a goal, if you have the data, that's good. That's a good starting point. But sometimes they don't have a good data science team. They didn't follow the rigorous data science protocols. They didn't do a very good job in data governance, model governance, peer review, and performance review evaluation. That's relatively easy problem to solve. You only need to have a better, probably some better or more experienced data scientists in team, then you can fix this problem. Then the fourth one is no deployment. That's what I talked about. So you build a good model, but it's just because the model is working in the laptop, in the data scientist individual's laptop, it doesn't mean it will work in the cluster. It doesn't, it works with even a million records of undersampled data. It doesn't mean it will work with 24/7 streaming data, because the data just coming in with different frequencies and different payload, and the stress is totally different. So if we cannot deploy the model in the production environment, we're not going to bring the value to the company. And the fifth one is, even if you have deployed the model, if you don't introduce the feedback into the product, you're not going to find a way to understand how your model performs in the real world. So the feedback from the customer is equally important. So those are the common titles of doing data science in business. Then I'll talk about, from another perspective, the education, the talent program in data science. So we know we have a lot of universities providing those programs for data science, and we have a lot of massive online open courses for give the certificate or training courses for data enthusiasts. But they all have some issues. Of course, I cannot speak for all of them, but it's just based on my limited observations. There are some obvious potholes here. And we know that data science, by and large, as a data scientist, we need some skill sets. And the skill sets, mainly we can say come from three pillars. So one is the mathematics, understandable. Another one is computer science. Then the third one is the domain expertise. So we, as a good data scientist, or even just average data scientist, we need to have some equipment from each of this domain. Mathematics, we need to understand how a probability is calculated. We need to understand what is the mean, what is standard deviation, what is the entropy, and what is the mutual information. Those kind of calculation are coming from mathematics. And computer science, how the data can be efficiently sorted, and how we can organize the data in a B tree. Those kind of basic computer science foundation is definitely an important part of data science skill set. And how we can manage how we can query the data from databases, and how we can efficiently save the data in what kind of format, and how we can deploy and install some packages in our computer. So those are such and such rely on some experience in computer science and computer engineering. And domain expertise is actually a hard one compared to mathematics and computer science. We often say, let the data tell the story. We don't need to, we don't want to intervene the process of the learning. We want data to tell us what's going on, what is inside the data. But that's, in some sense, that's correct, because we rely on a big amount of data to find out the patterns and insights into it, using the gigantic computer resources to do the mining, identify those patterns. That's true. But if we just fully rely on the data itself to tell the story, sometimes it can be very costly, very expensive. It takes a long time. And domain expertise is very, very important still in this age, and maybe in the next 5-10 years. It still will be very, very important for us to really understand the business and the domain we are applying data science to. So these three pillars go together, make this data science very stable. But yes, questions?
No, I think there's a name for the people in the center. It's called unicorn. It's very hard to find people who are good at all three. So usually you find people good at two.
Yeah. So try to put yourself in the bullseye of this, try to be the unicorn here. And I believe we can do this,
What's their compensation package? That's the most important.
For you, it would be $1 million. Okay.
I was having 20 years in the astronomy society. They just said the training program is much more difficult to training to be an astronomer.
Mm-hmm.
So they always try to program from domain part rather than from that part.
Mm-hmm. Mm-hmm. Yeah, this is a really hard domain expertise. Is hard.
Unfortunately, I found that today's education, especially for the data scientists, data science education, try to convince people get rid of the domain knowledge.
Right.
They just with their data tell us everything, actually nothing else.
Yeah, so that's kind of irresponsible. So that's the problem with the somehow with the university programs, because of course they cannot teach the expertise in each of the domain, right? They're not tailored to do that. But we have to emphasize the importance of understanding the business, understand the domain, and that's actually the students is lacking of. So there are some potholes of the DS programs. The first one is the curriculum. It's basically, I looked at a few programs from different universities. The program for data science is more like a mix of salad. You just put different vegetables together. So they handpicked courses from statistics, from computer science, from operations research, from mathematics. They handpicked the courses from all those departments and put them together as a data science program. But one course doesn't understand what another course is talking about. And they don't know how those courses should be organically and integrally and put them together to serve the ultimate goal of data science. So that's because usually the program directors or the program managers or directors, they don't understand what's the core of data science and how for example, the optimization is playing a role in the algorithms. and what kind of algorithms are using the most part of the optimization, and how each of the part of different courses support the different part of other courses. So it basically just mix everything together. Then they're using the tool sets, which is like 20 years ago. They're still using MATLAB. They're using very statistically heavy tool. Of course, this is changing. It's easy to change. They're not aware of the stacks the industry is using. One example is, recently I was trying to find some interns for the summer, which have some experience in Spark Scala programming. Then I post the job opening in LinkedIn, in Handshake, and overall I got 500 to 1,000 applications. Of course, I cannot went through all of those applications, but from hundreds of the applications I read, none of them actually mentioned Scala. Although I put very explicit requirements, say you need to have experience in Scala programming, but none of them actually learn Scala in the course in the courses, because no university is teaching this programming language. Not mentioning Julia, not mentioning Go, those very new programming language in machine learning and data science. So the university is really hard to catch the trend of industry, because the professors, they don't really work in the industry. So the unmatched tool sets is another problem. Then the third one is the course projects. They are doing the course projects with very clean data, usually small data sets, very well-defined problems. And when the graduates come into the job and industry, they feel it's very confused, very puzzled, because the data is not clean, data is too large, it never ends, and the problem is not defined. Basically the manager just said, do this, and they have no idea how to do this, and what is this? So because the professor didn't teach them, the projects in the courseroom, in the classroom, is totally different than the projects in the company. So incomparable projects is another problem. So that's our education, how we get the talent into data science, which is not really helping the business to bring the value of data science into the business. So there was one, actually, I have been teaching in George Washington University for, I was teaching data science, machine learning algorithm. I've been teaching that course for about 3-4 years. Like starting last year, I was trying to do something different. I want to challenge my student. I say, for this midterm project, I want you to do something different. Although this is a machine learning class, I want you to do something not too much related to machine learning algorithms. I want you to come up your own idea. So just view me as an investor, like angel investor. I have $10 million to invest you, but you need to come up with some unique idea, with some very sound machine learning technique, which is the core of your product, and have a good plan of making the product real, so that you can convince me that you can make this product and you can make money out of it, and also bring value to the larger world. So that's my assignment to my class. Come up with a good idea, do some designing of the product, and view this project from the product perspective. They struggle, they really struggle. So some of the students told me, this is the most difficult project I ever had. I have no idea how to do it. They're so familiar with solving the mathematical problems, they're solving equations. They're very good at crunching numbers. But when you ask them to come up with their own idea and put machine learning in that perspective and make a product out of this machine learning model, they have no idea. They don't know how to do this. So they struggle in many, many, many ways. So first struggle is they struggle to identify a unique real-life problem to solve. They think the world is perfect. That's nothing for me to do. I couldn't find anything to improve. So there are a couple of students come up ideas say, okay, I just want to build a deep learning network to predict the stock price. I want to make money from the stock price, the stock market. So it's definitely not very interesting topic for me. And by no means they can build a cutting-edge algorithm which will beat the Wall Street. They have no way. I mean, in the end, they just come up with a very just social idea of how to predicting the stock price. They just couldn't find other interesting topic to work with. But there is some good students. I remember there was one student come up with an idea of saying, can we predict the birds' migration path for this year before they really started the migration, so that we can help them to clear the path and preserve the population of the birds. They can collect the data on the bird species, the environment, the path, the traditional, the past path, and they try to actually it turns out every year the path is a little bit different. So they're trying to predict this year's migration path so that they can help conserve the birds population. I think that's a very, very meaningful project, and it's doable. So I gave that student A+. But for that stock price prediction, I gave them B. This doesn't make much interesting topic to me. So keep an eye on everything around us, and the animals, the environment, the business, and the transactions, and everything around us, the education. We always can find something we can use machine learning to improve, data science to improve. We're generating data, 24/7. We're generating data, every time. No matter we're sleeping, we're working, whatever we're doing, we're generating data. And if we can somehow get the data, then we can find a way to improve our life. And then they struggle to transform, if they find some problem, real life problem, but they have problem to transform the real life problem to a technical problem. If we cannot do that, there's still a huge gap between the very abstract real life problem to very concrete, very tangible technical problem. Only when we can convert that into a technical problem, we can express that in a mathematical way so that we can use data to solve it. Because data in computer is just a matrix. Everything we have to turn, whatever format of data, we have to turn that into a matrix or tensor. So basically tensor is just a matrix, or it's a high dimension matrix. So everything has to be represented in matrix format, which means we have to abstract the real life problem into a technical problem, into a mathematical problem. And students struggle with that. Then define the scope of the technical problem, identify the relevant data and the data sources. So those are the very closely related problems, and leverage domain knowledge to do some engineering, the feature engineering. So because they don't understand how the world is operating around us. They don't understand how, if we put an order in Amazon, how this order and the thing we're purchasing get to our the front door the next day. How this happened? For us it's so easy. Go to the website, make the clicks, and pay money. Then magically it will appear in the front door next day. But behind that, how that happens, we don't understand. So the business domain knowledge is something the students are really lacking. Then choose the most suitable machine learning techniques. Then once we build a model, how we can envision the part of the machine learning in the product, how they play a role in the product. So that's what I talked about. Machine learning is just a part of the problem. How they play the role, how they interact with other components in the product, we don't know. We have no idea. Then what's the end-to-end architecture to make this product happen? We have no idea. Nobody told us. And then how we can address the model efficiency, robustness, and consistency. They don't know. They have no idea. So that's the struggles of the average data science students in universities, I believe in massive online open training, open courses. Anyone who's taking those courses will have those kind of struggles or confusions because no one is telling those things. So why this matters? What it matters is actually comes back to the essential difference between data science and computer science or social or software engineering. So in my company we have data science team and engineering team. The org chart wise we are shoulder by shoulder, side by side, in the equal importance. But some other companies they may have different structure. They may have a software engineer team and data science team may be a part of the software engineering team, may be totally separate, but in the research team, that's what I have seen before as well. So we have a R&D department and data science is within this R&D department. So what we have been doing is, when I was in some other companies, we have this data science team. We spend a year to build a model. Then we document the model. We build the model in R, in Python, in Meetup, whatever language you want to choose, whatever package you want to use, as long as you get a good result. Then once we have a good result, we claim it's a success. Then we do some documentation. We document what this variable is, how we can do this feature engineering, and how to write this model, and how to call this package, and what the result you will get. Then we shift everything to the software team. The software team get a wiki page and say, how I can calculate this variable in Java, and how I can call this package, which is Python scikit-learn, how I can call this package in Java, how I can do this in Java, how I can do that in Java. Because everything in production is in Java. But we do everything in data science in R, in Python, in whatever language we want. So software team has to use another year to translate the code from R, Python, whatever language to Java. And they have to develop a lot of library and package from the scratch. That's 2 years to build a model and put that, if successful, and put that into the production. That's very, very expensive. But that demonstrates why this matters, because data science deal with data. Data is the blood and the flesh and the blood of business. Every business generates data. If any business not value their data, they're not going to last very long. So we are dealing with the most valuable elements in the business. Although the employer like to say the best or the most valuable assets is their employees. They're not. Employees not their most valuable assets. Data is the most valuable asset in the business. So we are dealing with the data. So that makes us the most valuable assets in the company. So everything we do will have very a huge amount of either positive impact or negative impact to the business. So that's important. And data science provides predictive insights which shall be actionable, which means will not be abstract. Data science is very pragmatic. Everything we produce, everything we output should be actionable, which means it should be able to put that into product and be able to interact with the customer. And the model is only part of the complex applications, as I mentioned. Important thing is there's no such machine learning solutions are framework agnostic, which means there's no universal silver bullet of data science model which can plug and play in any computer science or software engineering architecture. We have to develop our model according to the framework or architecture our software engineering has chosen, so that we can minimize the transition time from model building to production. This is very, very important in Celera. After I joined the company, I have been advocating that in data science team, we are using exact environment as the production user. So whatever cluster we have the same. Whatever database production has, we have the same. Whatever the production language they use, we use the same. So that every model we build, we can just simply push that to the production. They can just directly use, and that will minimize the iteration of the model build from version 1 to version 2 with minimal interruption to the business. And data changes all the time, and the model needs to be adaptive. So the model cannot be static, cannot be just sitting there without any awareness of what's going on in the data. This data changes all the time, so we need to have some monitoring mechanism to track the performance of the model, and so that we can adapt the model according to the data. That's also very, very critical. This is something I came up. It's a data scientist cyclone, which goes from top to the bottom, shows different levels of competency or expertise a data scientist may have. And the top level is just the capability of manipulating data. So I think everyone should have that capability or experience of just data munging or manipulating the data. You can use R, you can use data Python, pandas, whatever tool, but you can manipulating the data. So that's the foundation skill everyone should have. Then go from there. We should be able to build models with some common sense features. After you have to do some EDA, you identify the features, then use those common sense to build the features so that you can build a model, whatever modeling technique you may choose. Then the next level is you understand the business so that you can apply some subject matter knowledge into the future engineering. Although many people is a big fan of deep learning, it's just because deep learning, the deep neural network can take care of a large part of feature engineering. But that's not actually the truth. If you apply deep neural network to problems other than image recognition, other than the speech recognition, other than NLP, in many other disciplines, you still need to convert the data into something which can be fed into neural network. So you still need to use the domain knowledge to transform the data into something the deep neural network can understand. So the subject matter features is hard to build, to engineer. So that's why I put that in the third layer. Then the fourth layer is you will be able to configure the models with some discretion. You know what this model is doing. You know how to, each of the parameters or hyperparameters are doing, what they are meant to do. So you can configure the model so that you can optimize the performance of the model. Then the level next to that, which is even harder, is to identify and define problems to solve, which means you are now creating the new problems so that you can solve something new nobody is aware of. So that requires you to really understand what's going on in your business, what's really going on in this domain knowledge. Then the third one, the next one is the design and adjust architecture, which means now you understand the engineering part, not only just the data, not only just the model, not only just the business, but you understand engineering. You know how to put the machine learning model in the perspective of many, many other components so that they can work together and handle a lot of realistic challenges. Then the last one is you will be able to see those unseens. So nobody's seen that. Nobody has seen that. So this is require you have some vision into the business and see that in the future that will be problems we can solve, but nobody has seen that yet. But you see that, you define the problem, you can see that and then see that through, which means you can have a team to go through all the layers and finish and see that through. Oh, I think I'm running out of time. So how a DS grow? This is another interesting cartoon. It's using the story of Noah's Ark. But the animals are Hadoop is an elephant, pig is here. You have Python as a snake, So the Noah, as you self, you are trying to build, take all those animals into the data science boat. But the thing is, they're not that easy. How we can grow as a data science is not just a mixture of different programming languages, different tools. For a data science grow, I just go through these bullets. Then, first we need to understand the essence of the algorithms. So you don't have to, be able to code those algorithms from scratch because there are so many packages already implemented those algorithms. But it doesn't mean that you don't have to understand those algorithms. As a data science, you need to understand the essence of those algorithms so that you can pick which one to use from different, for different use cases from different environments. Then we need to develop the data intuition, which someone called data literacy, which is basically how we can sense the data or make sense of the data. Then we need to cultivate the business acumen. That's what I talked about. You need to understand your business, understand the problem. Then it's a very fast-growing discipline. Every day there are some Apache project come up and some open source project come up. There are always some new technique come up. So you need to keep yourself on the edge of the tech stack. Always try to explore some new tech stack. Then if you get the time and energy, trying to craft up your own projects and carry them out. So this is a really good process or practice of training the business acumen, training the sensitivity to the world around you. Identify something you can improve, so that you get a chance to build something as your own product. Then the last one is present more. Always find a chance to talk in a meetup like this, or write something like a blog post. Present your work to get interest, and also advocate yourself. Because if you view yourself as a product, you need to promote yourself. How to promote yourself? By showing something interesting to other people, which will be your own work. So present your work. And I saw there are a lot of students, they're really good at doing something, but they're really bad at presenting. They don't know, they are very shy, they're not very good at language, and they feel terrible to speak in front of other people. And they don't know how to organize the slides. Even though they have very good work, but they don't know how to put them together. So that takes a lot of practices. I'm going to skip, I have slides for each of them, but I'm going to skip that. Then how a business benefit. So I talked about the potholes, the problems. Then what is the solution? How we can solve those problems? So these are some of my thoughts. The first is get data. If you are in the software company, you shipped the product, and you don't own those data, but how you can get data? Find design partners. Find someone can work with you or willing to share data with you, even though you can give them some discount on the software or some other benefits, so that will be willing to share the data with you. Always try to get data. If you don't have the data, collect data and build data. And the second one is put the data science in the product design. When you are designing the product, involve data science team in the product design, so that they have a say on the features of the product, which powered by machine learning models. The third one is break the silos in the data and the domain knowledge. The common practice is in data science, each one is doing their own project. Like I'm doing my project, you are doing your project. I don't know what you're doing, don't know what I am doing. There are a lot of silos between data scientists, a lot of silos between different projects and different databases. We need to break that, because eventually we want to talk to each other. We want to integrate everything so that the business is not separate in silos, but it's just one sole business. Then the fourth one is bridge the data science and engineering. let them talk. So host some brownbacks so that invite a software engineer in the team so that data scientists present their work and let the software engineers ask questions. Or let the software engineer present their work, what's the cutting edge tech stack they're using and how they're supposed to take the data, consume the data, and send the data to the data science team. So let them talk to each other and get familiar with the terms. Importantly is we need to govern the data and the models. I think the financial industry is doing a fantastic job here. It's just because regulation. But in other industries, people are getting lazy in this. So once we build a model, we just discard everything before and use this model. Then until we have another model. But we need to govern the data versions and the model versions and document everything in details about what this data is. We should have maintained a data dictionary for the data. We should have a model repository for documenting all the model specifications and the performances. And the last one is take iterations. So don't have to force yourself to build a perfect model in the first iteration. It's totally okay to have a very lousy model in the framework so that you have the workflow and start it running. And then you can take iterations to polish the model. You can always come back and make the model better. The important thing is make the iteration happen. Make the snowball start rolling. So that's the idea, suggestions for the business, how they can make the best benefit out of data science. Then for the model, this is my last page, okay. A modern data science solutions usually have those features. So first is elastic. Because if we're dealing with a large amount of data, and the amount of data will go up and down. So usually we host those solutions in the cloud environment or in the data center environment, and we want to supply the computation resources in an elastic way so that the computation resources can go up and down based on the payloads. And we should modularize all the components. So each model should be just one component, should be just one module, and you should never put more than one model in one module. Because if one model fails, you'll not have to impact on other models. So modularize the components, the models in your data. So you have one module just purely doing the feature engineering. Once the feature is being created, just send out to other modules. Then you have another module to consume the features to do the prediction. Then the prediction will send out to some other downstream modules. And how to do the modularization? We use Kafka. So we use Kafka message bus to build a very flexible environment so that everything is just a component on the message bus which subscribe to some message and publish new messages. So you can just customize the layout of the components on the message bus. And it should be reactive. The product should be reactive, which means when the user is using this, it will not be blocked by some models. It should be always responding. Then the most important thing is should be robust and resilient. So if something broken in one of the components, your product still can work, and the broken part will be somehow identified and resurvived from the death and come back online and make it resilient. So reduce the offline time, which requires a lot of monitoring, automation, but we have the technical stack to do everything. So that's what we're doing in Stellara. We're really building a fantastic, very exciting software product which can handle a large amount of data in a streaming mode 24/7 in an elastic way and a robust way with the machine learning in the core. So that's what I want to share with you. In summary, you want to be a data scientist like her. So this is the perfect data scientist. You have an open mind, always willing to come to our meetup and meet new friends and see some ideas, have an open mind, be creative, have the idea of doing something nobody is aware of, nobody think of, and people think that's impossible, but you think it's possible. Be creative, and have a human heart. You want to use the data to do something good for the humanity. You don't do evil, right? So have a human heart. Then equipped with analytics. So you have the capability of doing the data analysis, machine learning building, artificial intelligence. And the important thing is know how to do the business. So you understand the business. You know the business and how it's operated. So that's the summary I have. Data science is scientific. It's not something secret. It's not something hard to understand. It's built upon a foundation of a good science. It's very pragmatic. So when you're doing data science, crunching data, looking at the model, you should always keep that in your mind is how I can use that model and how people can use that model. Because eventually, data science is pragmatic. And all business eventually will embrace the data and the data science and become data science business. So that's why I'm so optimistic about the future of data science, machine learning, artificial intelligence, because if a business not pay attention to the data, it will die. It will die soon. So what will survive is the business which value the data science. Because data itself is nothing. If you are not going to extract information or insights from data and utilize those insights, data itself is nothing, right? It's just binaries, 0 and 1s. It doesn't mean anything. So once you have made sense out of the data and put that in the business, the business will survive and thrive. So hopefully, this will just strike some echo from you, and if you have any questions, feel free to let me know. But this is really what I trying to share with you, not particularly any algorithms or marketing techniques, although I can do that. But I think this is way more important for the business, for the data science professionals to understand this and pay more attention to this. Thank you so much.